Hi, so let's talk a little bit about representing motion using rather representing forces using a force diagram. So I have some examples here, and what I'll do is I'll just sketch out the force diagram. So here we have a guy, he's pulling a crate across the floor. So our object of interest would be the crate, so we can draw that as a box, if my thing will draw. So my pictures aren't going to be very good, but bear with me. And then pulling it by a rope. So we know it's sitting on the floor, it's sitting on a solid surface. We can go ahead and draw that in just so that we know it's a solid surface. You put these little marks just to show that it's a solid surface. And then since he's pulling it by a rope, we know that that's going to be called a tension force. So we can just label that as a T, or you could put F with a little t. And then we also know it has some weight. So from center of mass, we'll come down, and that would be our weight or our force of gravity, gravitational force. And then since it's pushing on the floor is pushing back. So we're going to have a normal force that comes back up this way. And if this was a frictionless surface, we would be done. However, let's just assume that there's some friction. So that means that we're going to have some friction force coming backwards. And if it's moving, which this arrow indicates that it is, then that would be kinetic friction. So we just draw it like that. And that's our complete force diagram. All right, let's look at this next one. Similar situation. Let's say it's frictionless. Or no, we'll put friction. The only thing is that the tension is now at an angle. And so we'll go ahead and we'll start with our object. It's the crate. And the only things touching the crate are going to be the rope and the floor. So let's go ahead and just draw the floor. So we have the rope, and with tension, the tension is always along the same direction as the rope or chain or whatever it is. So we would draw our tension like this, label it, and then we might include that angle just so that when we have to do some calculations, we can deal with it. All right, and then again, we have the force of gravity or the weight, the gravitational force. And then since it's on a solid surface, we have the normal. And remember, the normal is always perpendicular to the surface. So the normal comes up like that. And then again, if we have friction, we would put friction this way. And since it's moving, that's kinetic friction. All right, let's look at something a little bit more complex. So we have a skier going down a slope. The slope is at some angle. We don't know what it is, but we have this skier. So let's just say that the skier is, we'll say like this, a blob. All right, so we know that there's some weight. So we have some gravitational force coming straight down. Gravitational force is always straight down. Now it's the normal. And so what you have to remember is that the normal is always perpendicular to the surface. So the normal is going to be pointed in this direction, perpendicular to the surface. So my normal is actually going to be off in this direction. I know that's not the right angle, but you get the idea. So this would be my normal force. And then even though this is snow, there's still a little bit of friction. And so since he's moving kind of in this direction, I know that he's actually turning, but we can go ahead and for simplicity's sake, just say that he has some friction force. He's moving. So yeah, let's just put we'll call it frictional force, because we'll come back and talk about which type this is. So we can just say it's a friction force. Not sure if it's kinetic or static. It's just friction. All right, the last two. So this one, I put this one because I want to talk about the ball, say here when it's going up and then when it's coming down, these two different things. So first I'm going to draw this one right here, this one. Okay, so the ball is going up through the air. And now we got to think about what's touching the ball at this point. That doesn't work. How about red? That ball. So what's touching it? The only things that's touching it is gravity. So it's only the gravitational force. This ball, even though it's flying in the air, it still has some weight. And so we have the force of gravity acting downward on it. It's a big F. there's nothing acting up. There's nothing else touching this ball, so there's nothing pushing it up. It's just in motion in that direction. The only force acting on it is straight down. And then if we come over here to the other side, when the ball is descending, let's do that again, and you should see that it's actually going to be the same force diagram. Because again, the only thing that's touching it is the gravitational force, the field force from a distance. So we end up getting the same force diagram. And this is going to be important. So you see the force is pointed down. That doesn't mean that the ball is moving down. It's just going to show us the actual acceleration of the ball. And that's Newton's second law we'll get into in the future. Okay, so the last one, we have this bag that's hanging here. So if we said that our object was the bag, we can go ahead and draw it. And then we have some weight. But then these straps are pulling it upward, and it's kind of hung up here. So these straps are like a rope, but there's two of them. There's one on each side, so we would draw those separately. We're going to have a tension over here and a tension over here. And in fact, we'll learn that these would be equal. But we can add multiple forces on one side if that's what it shows. These are actually at an angle. So probably would have been better. Let's just correct it. That way it's correct. So we would have a tension kind of in this direction, and then we would have another tension pulling in this direction. And then we can work with those angles and figure stuff out. But that's basically just identifying all of the forces, identifying the forces, drawing a force diagram. And then it's going to be important because we're going to take these things, and this is all going to be modeled with some math. So we'll develop some math fundamentals, principles that we can use to solve problems.